So in the old days, generators were a coil of wire for the field, and then they were several coils put together for the armature or the output, okay? And the field produced the magnetic field. We mechanically turned that magnetic field between these armature coils, and that magnetic field affected the electrons in the armature coil and moved them, didn't it? And it moved them to take care of a load, which would be maybe a battery, charging a battery in a car, whatever. There's like all kinds of loads, okay? Infinite loads, all right? What did we replace in our newer generators that were in the older generators? Now, none of you are probably old enough to remember a whole lot of those. Any of you got a car that has a generator in it? Nah, probably not. Not unless you own a really old car. I got a couple of them. You had one?
Yeah.
What was it?
65 Beetle.
Yep. Have a generator in it. And you had to, remember the regulator? The generator would lose its field a little bit and it wouldn't charge. So you had to short the regulator, and what it would do is it would make these laminations have a little bit of a field, so when you started the engine, it could pick it up and start generating. Otherwise, the generator just could not get started, didn't have enough field to get enough electrons moving so that it could charge the field from the generator through the regulator and actually start charging. It was interesting. We had to do that every once in a while. If you let a generator sit for a long time, then you'd have to do that. We don't have that problem anymore because we don't have generators anymore. Generators in cars were replaced with an alternator. Alternator has a field, but it has fingers, and it's actually an AC generator instead of DC. These were DC, okay? So they had enough armature coils, so when it came out, and when it came off of the armature, it came off on commutators, and every time the commutator would pass the magnetic field, it would cause it to have a little blip and a hump, and it would overlap, so that when you looked at it on a scope, it was just a bunch of little blips here. And what it did was, it would make the output look like almost DC. Now the battery acted like the capacitor. It simply allowed that to come in and dump into the battery, and then when you took anything out of the battery, that was DC. So it got rid of all the garbage, okay? Otherwise, if you used a generator just directly, you would actually, on a scope, be able to see the commutators passing. Now, did you guys study generators? You kind of knew how they work then, okay? So that battery, you knew that was kind of like a capacitor. It'd get rid of all of the little garbage on top, so it looked clean. Now, we'll use capacitors and power supplies later on to do that too. Now, what happened if you had a radio that you put into the car and it got that buzz from the generator? How'd you fix that? You remember? Mess around with the ground. But sometimes you couldn't get rid of it. You just hear that buzz from the generator. So they used to make capacitors that you could buy, and you just put them in line, and that took care of that garbage. Sometimes the battery couldn't take care of all of it, so you'd put that capacitor in there, and that'd take care of that garbage, okay? Alternators, we don't have that problem. In fact, alternators are AC generators to start with, okay? Now it's kind of funny in the book they talk about them, and they say, well, they're AC, and then and they act like the diodes are way up under the dash or something, but the diodes were in the alternator, so the output lug was actually 12 volt DC.